So now we'll start about the zener diode. In the zener diode symbol is like this, normal simple diode, and then place a Z like this across it. Okay. Zener diode only works in the case of reverse bias. Now there is two things you need to know about the zener diode. Like there is a standard and the fixed diagram of zener diode that you need to draw it for the every case. Okay, I'm not telling you everything into a detail, but I'm telling you according to your exam purpose only. So this was the standard diagram of the zener diode. Whenever they'll say you draw the diagram, draw this diagram. Okay, this one is the supply voltage that is denoted by Vs. This one is the Rs, series resistance. This one is the load resistance. Voltage across the load resistance is denoted by VL. Voltage across the zener diode is Vz, right? So basically we'll have two conditions in the numerical. As you know, your numerical only will come. One condition is Vz is greater than VL, means voltage across zener would be greater than VL, or one condition is Vz is less than V, right? So um, let's both these conditions. One of the condition is Vz is greater than VL, and another of the condition is Vz is less than VL. Okay. If the voltage across the zener diode is very large, then the current across zener diode would be very less, right? So we can consider it is approximately near to zero only. Now, if the current flowing in the zener diode is zero, then we can consider it will work as a reverse bias, right? In reverse bias, it will act as a off switch now. So if I'll redraw the diagram of the zener diode, again we'll have the supply voltage, then we'll have the series resistance. As current across the zener is zero, so make it open circuit. Rest of the diagram is same. This would be RL, correct? Now let us consider the current flowing in the series resistance is IS and the current flowing in the load resistance is IL, right? So can we say that if I'll apply the nodal analysis over here, can we say that IS would be equal to IL? Yes or no? Yes, now because there is no current flowing across the zener. Now we need to calculate the VL. VL is the voltage across the load resistance. VL is how much? We'll have, remember we have done voltage division rule in BET, right? So that would be total voltage Vs multiplied by, in whichever branch we need to calculate voltage, that is RL, divided by sum of resistor which are connected in series. So which two resistor are connected in series? That is Rs plus RL, right? So basically I simply apply the voltage division rule to calculate the value of RL. Next, we need to calculate IS. According to Ohm's law, I is equal to V by R. Yes. The voltage, total voltage is how much? Vs, and the total resistance is how much? Rs plus RL. Understood? Okay. Now we'll see the next condition. If Vz is less. If Vz is less, then current must be there. If current is there, then there must be some amount of current flowing across the zener diode, right? Now suppose this one is the load resistance, this one is the series resistance, this one is Vs, again Is current is flowing, and then now this time current is flowing across the zener also, so we can consider it as zener current, and here it would be the load current, correct? Now apply nodal analysis at this point and tell me the equation for the current. Is would be equal to, what does nodal analysis state? KCL state that is sum of incoming current is equal to the sum of outgoing current. Incoming current is Is, outgoing current is IZ plus IL, right? IS is we don't know, but we can calculate it. As you can see that this one and this one both are connected in parallel or not. So the voltage across zener would be Vz and the voltage across load would be VL, right? So can we say that the Vz would be equal to VL in this case? Okay. Now we need to calculate IS. IS is how much? Like suppose just imagine you are giving 220 volt at your home. You are giving 220 volt to the load and load is consuming 20 volt. Okay. Then how much is the voltage left for the series resistance, this resistance? Can you tell me? Total voltage you have supplied to 20 volt and from that 20 volt is consumed by this load. How much voltage is left for this resistance? Tell me. Like suppose you are giving 220 volt to your home. Okay. And 20 volt is consumed by the fan. Then how much voltage is left for the bulb? 20 minus 20, right? So can we say that yes, I minus VL divided by RS. Okay, because for that we need to calculate this voltage. IS is how much? V divided by R. R is how much here? RS. V is how much? That is VS minus. Understood? Okay. Now in every case we need to calculate whether this was the condition and this was the condition. So how will we able to calculate? By using this formula, the voltage division rule formula of V.